I'm Jae-Won. I'm happy to present my research results. Title of my research is Formally Verified Software Update Management System in Automotive. Before starting the presentation, let me introduce our research team. I'm a master student at Korea University School of Cybersecurity, and my colleague, Ji-won Kang is PhD student in the same university. We are currently conducting research under the guidance of Professor Seung-Joo Kim as a member of the same lab. He is our Professor Seung-Joo Kim. Isn't our Professor Lee-sung great? He is famous person for security in Korea. Presentation will be followed in 4 steps. First, we will explain the motivation for why we started this study, and after step 1, we will introduce the 2 methods we used in the research and some tips to be aware of when using them in step 2 and 3. Finally, in step 4, we will briefly introduce our follow-up research. Since the early and mid-2010s, research on car hacking has been steadily conducted. These results are continually announced at hacking conferences such as Black Hat. It made a vehicle manufacturer to require their products to remove vulnerabilities in its vehicles. A typical example is Charlie Miller's Jeep Cherokee hacking and recall of Fiat Chrysler. As a result, UNECE announced UN regulation to ensure the level of security of vehicles in 2020. UN regulations related to vehicle cybersecurity are number 155 and 156. Among that, UN Security 156 present requirements for a vehicle software update management system called SOMS. UNECE announced that OEMs who do not comply with UN regulations cannot export their vehicles in Europe. Therefore, OEMs must comply with UN regulations to export vehicles to Europe. However, there are some difficulties for OEMs to develop vehicles following UN regulations, because UN regulations only include abstract information without exams or guidelines. As a result, OEMs may not know how to implement these requirements when developing a SOMS because they do not have detailed information about which parts of the update are vulnerable and which countermeasures are appropriate to prevent manipulation. We use threat modeling to refine these requirements so that OEMs can refer to them when implementing a SOMS. Our entire research process is as follows. First, we identified all threats that could occur in the SOMS through threat modeling and derive security requirements to respond to those threats. And we designed the secure SOMS based on the requirements. After that, we formally specified the design through event B and verified that the specification worked without errors. Threat modeling is conducted as shown in this figure. First, we identified assets to protect, and in step 2, we modeling the system. In step 3, we collected a variety of information on all known vulnerabilities, threats related to the system. In step 4, we analyzed the attack surface using the STRAT method. In step 5, we made an attack scenario based on the collected threat vulnerabilities in the previous step. In final step, we derived security requirements that can make the system secure from the attack scenario. First, we analyzed the structure of the SOMS to conduct the modeling. Since we are not researchers applied with any company in the automotive domain, we refer to published documents such as papers and technical reports or deliverable in open source projects. Modeling means some process of abstraction, then removing the unnecessary information from the system. It helps to analyze the system. For example, suppose you are processing data to find the shortest route from San Francisco to Los Angeles. You can determine that middle figure is much easier to understand when calculating shortest route than left figure. Transforming left figure to middle one, this is modeling. We use a data-driven modeling technique called DFD. The reason for using this technique is to identify points where the data is exposed to hackers. These DFDs can be classified from context to level 1 according to the rigor of the expression. We created context levels based on roles such as OEM and client. In level 0, the context level was materialized based on the task that the role had to perform. In level 1, level 0 was materialized based on the function necessary to perform the task. After creating the DFD, information such as known vulnerabilities, weaknesses, and attacks that may occur in IT products similar to the system to be analyzed is collected through various journals, conferences, CVE, CW, and so on. And we collected 70 pieces of information using 41 CVE, CW, and 29 paper standard and technical reports. This collected information is called attack library. After collecting the attack library, we analyzed the attack surfaces based on DFD. As vehicles gradually become software-based electronic devices, OEMs are interested in the STRIDE methodology developed by Microsoft to evaluate the security of their software. For example, Kobesa, which members are various OEMs such as BMW and Hyundai, was also using STRIDE when analyzing attack surface of the vehicles. Therefore, we choose Heavens, which is based on STRIDE, to analyze the attack surface of the sums. STRIDE can identify threat based on two rules: STRIDE for interaction and STRIDE for element. STRIDE for interaction analyzes threat that can occur when each component interacts, and STRIDE for element analyzes threat that can occur in each component based on rules. However, STRIDE per interaction is more inaccurate than STRIDE per element. Therefore, we used STRIDE per element to analyze threat in sums and identified 1007 threats. After analyzing attack surface, we derive an attack scenario that can actually occur based on the identified threat. At this time, threat can be specified as scenarios based on the information in attack library as shown in the figure below. Through this process, we totally derive an attack scenario related to 4 general attack goals for sums. The goals of each attack scenarios are automotive obstruction, automotive control, server obstruction, and server control. Based on the attack scenario, we derive the security requirements needed to design a secure sums. Access control and authentication requirements has been derived to respond to hacker attacking OEM servers or vehicles through authentication, authorization-related vulnerabilities, as shown on the left. When driving these security requirements, ISO 15408 was referenced. After that, we designed the secure sums based on the derived security requirements. The following figures show the design result for the sums based on the deployment diagram and component diagram of UML. Afterward, we specify the UML-based design using event V, one of the formal methods, and verify that the function related to security requirements work properly without conflict. The formal method is used for developing systems that can help to eliminate error during the system development life cycle. However, the formal method is difficult to learn due to its mathematics-based syntax. Therefore, many companies are not using the formal method because of the time and financial cost which is consumed on training. However, some organizations such as NASA use formal method. According to the research of NASA, by using formal method, they eliminated vulnerabilities at a much lower cost than ever, so we use them too. Among formal methods, we used Event B. Event B is actively used in safety-critical systems such as railways and aviation domains. It can be written in loading platform and verified by the Atelier B engine. We formally specified our architecture as shown in this figure. In the figure, you can find that requirements related to authentication and authorization are implemented in login function in loading platform. We formally verified that our architecture works properly without errors. As evidence, we show our proofs and as shown in the following figure. We conducted threat modeling to derive security requirements with specific information. Based on security requirements, we designed the architecture of secure sums. After that, we formally verified that our architecture has no errors. Nowadays, we are trying to generate source code for the sums. If this research is completed, OEM will be extremely helpful in deploying sums. Thank you for listening to my presentation. If you have any question, please feel free to ask.